Hello everyone and welcome to this video. Today we're gonna discuss the second partial derivatives. So we're gonna solve some examples and discuss those. So we have, for example, find all of the second partial derivatives of the following functions, and we have some functions listed. So now first, for the second partial derivatives we could have multiple options. So the first option is that we differentiate f with respect. So we differentiate f first with respect to x, and then we differentiate it again with respect to x. So this is our first option, which is basically dx squared. Now this is our first way to getting the second partial derivatives. Now we have a different way or a different path, which is basically differentiating first with respect to x and then with respect to y. So this is the second partial derivative, dy dx. Now the third way is that we first differentiate with respect to y and then with respect to x, so which gives us the second partial derivative of dx dy. And our other way is, or fourth way, is that we differentiate with respect to y and would differentiate with respect to y again. So this is our third way of getting the second partial derivative. So we have four partial derivatives that we need to evaluate, since he asked us to find all of the second partial derivatives of the following functions. So let's start with example A. So we have the function f of xy equal x to the 4 plus 6 square root of y minus 10. Now let's start doing, also this can be written as f xx or f xy, and this is f xy, and this can be written as can be written as fyx, and this can be written as fyy. So first let's try to find fxx here. Let's try to find first the partial derivative of f with respect to x, and then differentiate that fx, which is basically, now if we differentiate with respect to x, we need to let y to be constant and then differentiate x. So we're gonna have fx to the 3. Okay, and then we can find also from that, we can find if the partial derivative of f with respect to y. So this is gonna be 6 over 2 the square root of y, and we take x as a constant. Now from here we can get the second partial derivative. So we differentiate with respect to x, which gives us 12x squared. Now we can also get fxy, which is gonna equal 0, since we don't have any y here in fx, and we treat x as a constant, so all of this will be treated as constant, so it's gonna be 0. Now from this we can get fyy, which is basically, if we rewrite this, now this can be, we can have, it can be written as 3 over square root of y, which is basically 3y to the negative 1 over 2. Now if we differentiate that, we're gonna get negative 3 over 2 y to the negative 3 over 2. Now this is the second partial derivative with respect to y. Now if we do yx, we're gonna basically get 0, since we don't have any x's and y is treated as constant, we're gonna get 0. And that's the solution to the first example. Now, if you've noticed, if xy is equal to fyx, as you can see, this is not a coincidence, so this is not something that usually happens by chance. So this is actually a rule. So or a fact, let's call it a fact. For most f of xy, if xy is gonna equal fyx. So for most functions, f of xy is gonna be equal to fyx, and that's basically a fact. Now let's solve the second example. We have w equal x squared y. Okay, so we have w equals x squared y minus 10y squared z to the 3, y squared z to the 3 plus 43x minus 7 tan 4y. Okay, so this is a function of 3 variables. So we're gonna try to evaluate. So first we have fxx, fyy, fxy, fyx, and we can also do fxz, fyz, and fzz, fzx, fzy. So we can evaluate all of these, and yes. So let's start with fx, basically a simple one. So this is gonna be 2xy plus 43, and then fy is gonna be x squared minus 20yz to the 3. Okay, this is z. And then minus 4 times 7 says 28. And then the derivative of tan, which is times 1 over 1 plus 4y squared let's double check. Okay, sorry, it's secant squared. This is the derivative of tan inverse. So secant squared of 4y. Now we go for partial derivative with respect to z. Minus 30 y squared z squared. And that's it. So now from here we can get fxx, which is 2y, and then fxy, which is 2x, and then fxz, which is 0, treating everything constant. Now for fy, we get fyx first, it's just 2x and then fyy is just minus 20 z to the 3, and then we want to take the derivative of secant squared, which is, so secant squared is 1 over cosine squared. Okay. And we want to take the derivative of that, so let's, just so I don't say mistake, so let's say derivative of secant squared 2x. Okay, so it's secant 2 secant squared x tan x minus, of course we apply the chain rule, so 4 times 28, I'll use my calculator, 112, and then we multiply by 2, secant squared 4y tan 4y. Now, so 2 secant 2x tan x, okay, and this is the formula, so we can basically multiply this by 2, we get 2 to 4, 2 to 4 times secant squared 4y times tan 4y, and this is the partial derivative with respect to y, and last we have the partial derivative first with respect to y, then with respect to z, which is gonna give us minus 60 y z squared, so multiply 3 by 20, and then that's it. Okay, so this is fx, this is fy, and this is fz, and these are our resulting second partial derivatives, and finally we do our last partial derivatives. So we're gonna get fz with respect to x is 0, fz with respect to y is minus 60y z squared, and then fz with respect to z is just minus 60 y squared times z, and that's our answer for example 2 or example B. Now we can try this if you want to really test your understanding. You can try this. So I will solve now number C, or example C, part C. So h of st, t to the 7 ln of s squared plus 9 over t to the 3 minus the 7th root of s to the 4. Now we can find here fst, we can find fts, and then fss and ftt. So now let's rewrite this so we can easily differentiate. So first we can write t to the 7 ln of s squared plus 9 over t to the 3 minus s to the power of 4 over 7. Now let's differentiate, find fs. F with respect to x, the partial derivative with respect to x to s is squared is 2s t to the 7 times 1 over s squared minus 4 over 7 s to the power of 4 over 7 minus 1, which is minus 3 over 7. Now this can be simplified. So 2t to the 7 over s minus 4 over 7 s to the negative 3 over 7. And that is fs. Now if we want to find if the partial derivative with respect to t is gonna be 7t to the 6 ln of s squared plus, let's rewrite this as 9t to the negative 3, so minus 27 t to the negative 4. This is the partial derivative with respect to t. Now from this we can rewrite this as 2t to the 7 s to the negative 1 minus 4 over 7 s to the negative 3 over 7 to make it easier to differentiate. So now the partial derivative with s first, and then we do with s again. So now we have minus 2 t to the 7 s to the negative 2, and then we multiply minus 4 over 7 by minus 3 over 7. This will give us plus 12 over 49, and then minus 3 over 7 minus 1, which is s to the power of negative 10 over 7. Now we know how we do the derivative, the regular derivative. We multiply the power by the coefficient, and then we subtract 1 from this whole power. So this is how we differentiate, basically. So now we did find f with respect to s. Now we can find fs with respect to t. So now this becomes 14 t to the 6 s to the negative 1, and that's it. Now here we find it with respect to s. Now this gonna be 2s times, so 14s t to the 6 times 7, 1 over s squared. This is the derivative of ln of any function. The derivative of ln of any function is 1 over the function inside the ln function. So, and then that's it. This can be simplified to 14 t to the 6 s to the negative 1, or 14 t to the 6 over s. Now if we do ft with respect to t, now we're gonna have 42 t to the 5 ln of s squared minus 27 times 4, which is a plus 108 t to the negative 5. And these are our final answers for this question. This and this. These are all the partial derivatives. Now, just to make you aware, we are finding all of the partial derivatives for this function. Usually we might just need one of these four. We might not need them all. But now for our example, he's asking us to find all of them. So that's what we are going to do, and that's what we have done with our first example. Now let's solve our last example, which is D. Now D is f of xy cosine of 4 over x e to the x squared y minus 5 y to the 3. Exactly. Okay, so now let's start with what can we find? We can find fx, fxy, fyx, fyy. Let's start with the partial derivative with respect to x. Now we're gonna apply the chain rule. For the first one, we're gonna have y minus sine of y over x. Actually, applying the chain rule will give us negative y over x squared. And then the negative sign is from the sign, from the differentiating cosine. This gives us the negative sign, and then the chain rule, x to the negative 1, negative, and then 1 over y over x squared. And then we multiply it by x squared y minus 5y to the 3. Now for our second part of the chain rule, we're gonna do cosine of the product rule, cosine of y. Let's make sure, is this y or 4? Okay, this is 4. Okay, this is 4. This is 4, and this is 4. So cosine of 4 over x. Now we differentiate this with respect to x. So we're gonna apply the chain rule here. So we're gonna get 2xy times e to the x squared y minus 5y to the 3. Now let's try to simplify this. So we're gonna get fx equals e to the x squared y minus 5y to the 3 times minus 4 over x squared sine of 4 over x plus 2xy cosine of 4 over x. Now this is our answer for the partial derivative with respect to x. Now from here we can find the partial derivative with respect to y or with respect to x. Now let's try to do it with respect to y. If we would do it with respect to y, all of this will be regarded as a constant since there is no y's. So we're just gonna differentiate e to the u and then plug that as a constant. X squared sine 4 over x plus 2xy cosine of 4 over x. And then we're gonna have x squared minus 5, this is the chain rule, 15 y squared e to the power of x squared y minus 5 y to the 3. That's our partial derivative. Now if we want to evaluate it with respect to x, it's gonna be a bit complicated, a bit more complicated. Sorry. Now we're gonna apply the product rule, but we're gonna apply it multiple times for this example. So the first time we're gonna apply product rule for this term here, the exponential term, and then we're gonna apply it for this term, which also involves another product. So involves products of functions, which will require us to apply the product rule twice. So now let's do this. So 2xy times e to the x squared y minus 5y to the 3 multiplied by our function sine of 4 over x plus 2xy cosine of 4 over x. Now we add that to e to the x squared y minus 5y to 3. Now this is the second part of the product rule. So we're gonna do this basically. So first we're gonna evaluate the derivative of this term. Now the derivative of this term will require us to do the product rule. So we're gonna do basically, this is minus 4x to the negative 2. So it's gonna give us 8x to the negative 3. So 8x to the negative 3. Now we are doing this term. So 8 to the x negative 3, because this is basically minus 4x to the negative 2. We're gonna differentiate that and get this, and then times sine 4 over x. Now the second part, let's just change colors so you can see what's happening here. So this is our part. Now let's continue, and then we're still in the first term, so we're gonna do minus 4 over x squared times minus 4 over x squared times sine of 4 over x, and that's the derivative of our first term. Now we can simplify this, of course, so we can get here, we can do plus 16 over x to the 4 plus 16 over x to the 4 sine of 4 over x. So this actually is gonna be cosine of 4 over x since we differentiate. Now for our second term, can use a different color. Now this is our second term, as you can see. So let's do that. Now first we differentiate, so we're gonna get 2y cosine of 4 over x plus 2xy times, so yes, so we're gonna get minus first, we're gonna get minus, so actually I think we had a mistake here. Let's come back here. I want you to notice this. So here, basically, when we differentiate the first term with respect to the first term to find our first term in fx, differentiating cosine will give us a negative sign. Okay, and then differentiating this part inside the sign will give us also a negative sign. So it will give us negative 4 over x squared. And these two negative signs should cancel, so we get a positive sign. Now here we can just change that. So this is positive. Okay. And then here we can just change that here. So this is positive. Fix with respect to y. Okay, and here this should be positive. And so we're gonna get a negative sign here by differentiating. Also, for our other part, we're gonna get a positive, and then differentiating will give us a negative. So here we're gonna have also a negative sign. And then for the second part, it's just the same. So that was the basically the issue here. So and that when you get this minus sign, we then do the same thing, minus 4 over x squared sine 4 over x. Oh, this is a bit of a complicated problem, but now we found this function. Now let's try and add the terms basically. So let's see what can we do regarding the terms. Try to find common factors. So our first common factor is just e to the x squared y minus 5y to the 3. And now we have this. So we get 8y over x sine 4 over x plus 4x squared y squared cosine. Now we're multiplying this by this and this by this. So cosine 4 over x. Now we add the terms down. So 8x minus 8 over x to the 3 sine 4 over x minus 16 over x to the 4 cosine of 4 over x plus 2y cosine of 4 over x minus 2xy okay, this can be simplified to plus 8 y over x sine of 4 over x. Now can we find some terms that we can cancel? I can see some terms that can be put together. So I see here x over y y over x. So this term and this term can be added, and that's it basically. So I can do just this. We do 16y, and then I remove this. We can further simplify this by doing fxx equals e to the x squared y minus fy to the 3 multiplied by, now we can get all of the cosines and sines. So for the sines we can get 16y over x, now this, minus 8 over x to the 3 at the bracket, times sine of 4 over x, and then we do plus 4x squared y squared, so the bracket, minus 16 over x to the 4 plus 2y multiplied by cosine of 4 over x. Side square bracket. Now this is our answer, as you can see. It's our final answer for fxx. Now let's continue. So we need to find now f y x so we found xy. So let's find now first fy by itself. Now fy is gonna be a bit easier since we're gonna treat this as a constant. So cosine 4 over x is a constant, so basically we're gonna put it here. Cosine of 4 over x is a constant multiplied by x squared minus 15y e to the x squared y minus 3 minus 5y to the 3. Now this is our fy. Now from here we can find our fy, which is basically we're going to treat this as a constant. So we're going to apply the product rule. Cosine of 4 over x, have it at the beginning, and then we're going to have minus 15 times e to the x squared y minus 5y squared, 5y to the 3, plus x squared minus 15y, and then we differentiate with respect to y, so x squared again minus 15y e to the power of x squared y minus 5y to the 3. And that's our answer for fy. Now this can be further simplified, so we do cosine of 4 over x e to the x squared y. If we take it as a common factor, y to the 3, we can get basically this x squared y all squared minus 15. And if you want to simplify this, you can, but I'm not going to do that. And then we now find, now this is the answer. Now we find fy with respect to x, which is basically is gonna be applying multiple product rules. Okay, so first let's divide the function into two parts. So this is one part, so this is our first part, the cosine, this is our second part, and then we're gonna differentiate the second part. So we have two parts, separate parts, and we're gonna try to differentiate them. So our first one, we're gonna have minus times minus 4 over x squared cosine of 4 over x. Now I differentiated cosine of 4 over x. Now this is gonna be just 4 over x cosine 4 over x. Now this is gonna be multiplied by, now we're gonna differentiate the second part, which gonna require also a product rule, another product rule. So we're gonna try to do that and differentiate. So our first part differentiating with x is gonna be 2x multiplied by e to the x squared y minus 5y to the 3, and then getting the second part x squared minus 15y, and then differentiating the exponential, we get minus 15y, of course with respect to x. So if we differentiate with respect to x, we're not gonna get this, we're gonna get something like 2xy multiplied, of course, then by the exponential itself, x squared y minus 5y to the 3. Now this is our first part of the product rule. Now we can go for the second part, which is cosine of 4 over x multiplied by, okay, I think, yeah, no, I think I think it's correct. I think just we have a minor issue here, so I should have not differentiated the second part, since I already differentiated one part. So I can do just simply this. I will tell you now exactly what I have done. So here just should have been simply x squared minus 15y times e to the x squared y minus 5y squared. Now this is our second part basically. So let's show you. Now this is in the orange, this is the derivative, and this is first part. Now this is a product rule basically. So now, and this is our second part. So I just basically copied the second part from our function fy, and I've plugged it here, and then I have differentiated the second part. So this is derivative here, this is derivative. Okay, so derivative and this is basically our final answer. So I already found the derivative for this part, and here I did not need to find the derivative, just needed to substitute, and that's our final answer. It's a bit messy. The problem is a bit messy, I know, but these are our final answers for the second partial derivatives. Okay, now this, and this is our other answer. It's this one, and also this one. So these are our second partial derivatives, and that's it for this video. Thank you for watching.